Virgin.
Yes, Meilisa.
Before we go to sleep, let's learn first about permutations.
Oh yeah, oh my god, this is so much fun.
I will explain what permutation is. Explanation of permutations. Basic definition: a permutation is the rearrangement of a set of objects into a different order. The crucial keyword to remember in permutations is, order matters. This means that the arrangement $A, B is considered distinct from the arrangement $B, A. If we have $N distinct objects, the number of ways to arrange these objects is referred to as a permutation. General formulas: permutation of all $N objects. When arranging all available $N objects, the formula is $N. $N factorial. P n equals n. Permutation of R objects from n available objects. If we only select a portion R from the total available objects n, the formula is cheeky smiley face n. R equals frac n. R, where n is the total number of items, and R is the number of items being ordered. Types of permutations. Permutations with indistinguishable objects. If within the $N objects there are groups of identical items, for example, the letters in the word banana, the formula is divided by the factorials of the counts of each identical element. Circular permutations. This is used when objects are arranged in a circle, like people sitting around a round table. Since there is no fixed starting point. Suppose there are 3 people A, B, C who will sit in 2 available chairs. How many ways can they be seated? Since the order of seating matters, who sits in chair 1 versus chair 2, we use permutations. In-depth explanation of permutations. The slot logic multiplication rule. The easiest way to understand permutations without memorizing formulas is the slot filling method. If you have 3 empty slots and 5 different objects. 1. The first slot can be filled by 5 choices. 2. The second slot has 4 remaining choices, since 1 is already used. 3. The third slot has 3 remaining choices. The total number of ways is 5 times 4 times 3 equals 60. This is formally written as P5, 3. Advanced permutation variations. 1. Permutations with repetition. If an object can be used more than once, like a padlock code or pin where numbers can repeat, the formula is n*R. Example, creating a 4-digit password using digits 0 to 9. Total ways. 10*4 equals 10,000. 2. Permutations with constraints. In discrete mathematics, we often encounter conditions. For example, arrange 5 people where person A and person B must sit next to each other. Strategy. Treat A and B as a single unit, a block. Now you are arranging 4 units, block A, B, C, D, E. Calculation. $4 times $2, where $2 accounts for A and B swapping places within their block.
Meilisa, I want to ask.
Oh yeah, Virgin is very capable.
Why are permutations vital in computer science?
In data structures and algorithms, permutations are used for optimization. Finding the shortest path, e.g., the traveling salesman problem involves evaluating permutations of routes. Cryptography. Shuffling the order of bits or characters to encrypt messages. Discrete probability. Calculating the likelihood of specific events occurring within an ordered sample space. Conclusion. Permutation in discrete mathematics is a technique for arranging objects where order matters, meaning the sequence AB is distinct from BA. Mathematically, this concept is rooted in the use of factorials n to determine the number of possible positions that a set of objects can occupy. There are several formula variations depending on the constraints. The standard formula Pn R equals n minus R. N is used for arranging a subset of items, the n-1 formula is for circular arrangements, and nr is applied when repetition is allowed, such as in pin codes. The essence of permutations is to solve the question of how many ways we can structure rankings, schedules, or passwords to ensure every possible sequence is accounted for. That's all the explanation from me, thank you.